Okay, so number 9, this is from section 3.9 notes. Number 9 says that the spread of a flu in a certain school can be modeled by this equation. P of t equals 100 over 1 plus e raised to the 3 minus t. So part A says estimate the initial number of students that are affected by the flu. Okay, so first of all, we know that t is going to be representing the days, right? And then P of t is the total number of students. So P of t is the number of students. So in order to estimate the initial number of students affected by the flu, that means that when the flu first started, so for A, it's going to be P of 0. Okay, so the initial number of students affected with the flu, it's when t equals 0. So P of 0, 100 over 1 plus e, 3 minus 0. Which when you solve this to the nearest whole number, because students cannot be halves, 100 over 1 plus e to the 5, e to the 3, this is actually equal to 5 students. So at the start of the flu, there are 5 students affected. So on the 0th day. Alright, B, we want to estimate how fast the flu is spreading after 3 days. So basically, if you remember, this is from a previous section, we want to find the rate. What is the rate at t equals 3? So what we want to do is, of course, we want to find the derivative. We want to find dp dt. So what is the derivative of this function? So obviously this is, it looks like a division, like a quotient property, right? But I'm actually going to rewrite it by taking this whole thing and putting it into the numerator and turning this into 100. So I want to find dp dt of 100 times 1 plus e to the 3 minus t to the negative 1. So just turning it into a product property rather than a quotient property. Alright, so now let's find the derivative. So first off, what's the first thing that we need to do is, if you think of this as a power property, it's 100 times the derivative of this thing. So the derivative of 1 plus e to the 3 minus t to the negative 1. Now obviously this looks like a chain rule because it's a function within a function. So the out is u to the negative 1. The in is 1 plus e to the 3 minus t. So the derivative of this guy is going to be negative 1 u to the negative 2. And the derivative of this, remembering, this is 0. And then of course, derivative of e to the 3 minus t is e to the 3 minus t times the derivative of 3 minus t, which is negative 1. Alright. And then thinking of the product rule, the reason that I'm not going to worry about the second part is because when you do plus the second guy times the derivative of 100, what's the derivative of 100? It's 0, so that whole second part ends up canceling out. So what we're left here is equals to 100 times the derivative of this, which is negative 1, u, what is u? 1 plus e to the 3 minus t raised to the negative 2 times this, which is negative e to the 3 minus 2, t, sorry. And now we're just going to clean this up a bit. So this is 100 times negative 1 times this negative 1, which ends up being negative 100. This part right here is, of course, going to come down to the denominator because of that negative 2. So this becomes 1 plus e to the 3 minus t squared. And then this part right here is staying up top. So there's the derivative. There is the derivative of dp dt. And now remember, we're finding this rate at t equals 3. So at this point, all we need to do is plug in three in for t. And then this ends up being e to the 0 is 1, so this is negative 100 over. Oh my god, I don't know why I just kept that as a negative, because these two negatives are going to cancel each other out. So this is actually going to become a positive. So positive 100 divided by 4, and that is going to be 25 students. So it's spreading at a rate of 25 students per day. Okay, so we're spreading at a rate of 25 students per day. Alright, so the last part, I need to do another video because my 4th hour students are standing outside. So I'll do another part video for this, and I will include in the next video a mini review of the past 3 sections, which include implicit, inverse trig, and log derivatives. Okay, so we still have to do part C. We'll do that in another video. Alright, see you guys.